Welcome back again, 7th graders, to lesson 12.2. I can find the probability of independent and dependent events. So these two are words that we're going to need to know, but I think that we do have a pretty good understanding of something that's independent versus dependent from math, from science, from real life. Absolutely, you're independent, you can do things without the support of something else, whereas if you're dependent, you rely on another piece, another event, or something like that. So they're pretty self-explanatory words, hopefully, at this point. Page 637 is where we'll start. Just looking at this situation here first. In sales, a sales advertises that you buy an item from the column on the left when you get a tote bag free. Suppose you choose items at random. So if you get a t-shirt, a jacket, a hat, beach towel, visor, or polo shirt, that's 6 different options, and there's 3 different colors of bags. So you look, what is the probability of buying a beach towel? Well, there's one. Beach towel is 1 out of the 6 items. So the favorable outcome out of the possible, so it's 1/6. Receiving a red tote bag, red is 1 of the 3 options, so that's 1/3. What is the product of the probabilities? So again, that's going back to those compound events when you do 1/6 of a chance times 1/3 and get 1/18. So some different things for vocabulary. A compound event. A compound event consists of 2 or more simple events. So in that situation, that's when you're thinking, first I'm getting a tote and what's in my tote type of thing. So 2 events together. An independent event is the outcome of one event that does not affect the other event. So, maybe the color, what you get inside the bag doesn't really matter based on the color of what tote it is. But this is the probability of independent events, something we're going to be looking at today. Probability of A and B is really the probability of A times the probability of event B together. And you've already experienced this a little bit because we did 12.3 ahead of time. So this should be okay, just some new things and a little bit more advanced in the type of things that we look at. So an example would be one letter tile is selected and the spinner is spun. So those are 2 separate events. You have to pull a letter tile and spin. They don't happen at the same time. So we're wondering, what is the probability that both would be a vowel? So you think, okay, the probability of selecting a vowel, and remember this is how you write this, and this is what we expect to see, is 2 of 7. How would we get that? Well, you have to think, what are the vowels? E and A are my vowels, and the rest are consonants. So we have total of 7 tiles on here. Okay, so we have 1, 2, 3, 4, 5, 6, 7, and there's 6 here. What is the probability that both would be a vowel? So selecting a vowel out of the tiles is 2 out of the 7. Spinning a vowel is 2 out of the 6 total, which simplifies to 1/3. And so both being the situation, so if we get a vowel here and a vowel there, that's 2/7 times 1/3 for 2 out of 21 possible chances for the probability. So we think that both letters are A's. Well, there's 1 A out of the total 7 tiles, so that's 1/7 when we're selecting it, and that's 1 out of the 6 when spinning. So that's going to be a 1 out of 42 chance. Both are consonants. Well, we have 1, 2, 3, 4, 5 out of selecting the tile. And I believe we have 4, 1, 2, 3, 4 when spinning. 4/6 though is the same as 2/3. So you're multiplying 5 times 2, which is 10, 7 times 3, which is 21. So it looks like the chances of them both being consonants is a little bit more likely than them being both A's or both vowels. So you could say selecting and spinning both consonants is more likely than spinning and pulling out 2 vowels. So a little test example, a spinner and a number cube are used in a game. The spinner has an equal chance of landing on one of the 5 colors, red, yellow, blue, green, and purple. The faces of the cube are labeled 1 through 6. What is the probability of a player spinning blue and then rolling a 3 or 4? So these are options. What you'd start is you have to read the item and understand what it's asking you. So after I've read this, I realize that I'm being asked to find the probability of the spinner landing on blue and rolling a 3 or a 4 on the number cube. Okay, so blue and 3 or 4. So we look for what the question asks. The events are independent because spinning the spinner does not affect the outcome of rolling a number cube. So these are independent events. So I'm going to solve the item. So first I find the probability of each event separately. So the probability of getting a blue is 1/5. The number of, so it's a 5 equal parts spinner. One of the options is blue out of the total 5. A 3 or a 4 on a number cube, that's 2 of the 6 numbers. So that's a 1/3 possibility. So then I find the probability of both of the events occurring. So the probability of getting a blue and getting a 3 or 4 is 1/5 times 1/3. So the probability of 1/15. So the probability is 1/15, which was in our first answer, C. So it's really important in these word problems and these probabilities where you really understand what is being asked of me and what information do I need to do here. So compound events. So now we're looking more at the independent or the dependent events rather. This is the outcome of one event affecting the outcomes of another event. So everyday use, we think of dependent as under the control of something else. In math, we're thinking on relying on another quantity or action. So think if you are going to draw something out of a bag and you don't replace it. So say you have you have a bunch of number cubes in the bag. You have 5 different dice and maybe they're different colors and you pull out the yellow and you don't put it back in. That's one less option you have the second time you pick up. So this is B following A. So you have to do a little bit of subtracting and taking out a turn on this one. And this is really important for you to remember when it says is not replaced or something's not put back when you're doing something. So if we're looking at dependent events, fruit. There are 4 oranges, 7 bananas, and 5 apples in a fruit basket. Megan selects a piece of fruit at random, and then Terrence selects a piece of fruit at random. So we're finding the probability that 2 apples are chosen. So what you have to think is if Megan pulls out an apple, that's 1 less apple for Terrence to choose. Or if she takes out a banana, if she took it out, Terrence can't have that same one because she already has it. So you have to kind of withdraw something from your sample size. So since the first piece of fruit is not replaced, the first event affects the second event. So this is a dependent event where Megan's choice will affect Terrence's choice. So the probability of the first piece is an apple. Well, we added 4 and 7 and 5 to find out that there are 16 total pieces of fruit. 5 of them are apples. So there's a 5 and 16th chance that Megan will get an apple. Whereas Terrence's then, the second piece is an apple. Well, 4, because if Megan took one out, that's 1 less apple. So there's no longer 5 apples, there's only 4. And there's no longer 16 pieces of fruit in the basket, there's 15 because Megan took 1 out. So we had to take 1 away from those different numbers. So the number of apples after 1 is removed, total piece of fruit after 1 is removed because the second draw is dependent on the first draw. So the 2 apples then, so 5/16 times 4/15. Doing some cross canceling, 5 goes into 5 once, 5 goes into 15 3 times, 4 goes into 4 once, 4 goes into 16 4 times. So you end up with 1 times 1 is 1, 4 times 3 is 12. Say you're not very comfortable with the cross products, then you could do 5/16 times 4/15. And then you end up with 20, 4 times 5. And you'd end up with 240 on the bottom. Cancel your zeros. 2 goes into 24, 1/12 of the time. So you just have to remember to simplify at the end if you don't cross cancel ahead of time. So you can check your progress here. refer to the situation above and find the probability. So same thing if we're going with bananas. Okay, we're going to get bananas. And this is maybe we start over. This is their first selection. So again, we'd say, okay, then the probability that the first is banana. I'm just going to abbreviate for the writing's sake. Well, there are 7 bananas, says, out of the total of 16. If the second's a banana, but Megan already took one out, that means Taryn only has the 6th of the 15 option. So you'd multiply those two together before you cross cancel as well for 7/40. Doing an orange, then an apple. So if I do E, if I do an orange and then an apple, so I do the probability of the first one being an orange. Well, there were 4 oranges out of the 16 chosen. And then for his second choice, the second was an apple. Well, there are now only 15 pieces of fruit, but there are 5 apples. Then you multiply those together. You can cross cancel first for 1/12, and so on and so forth. So you could try F and G, and then I'll uncover the answers. So knowing it does make a difference if it's the same fruit, you have to take from both the top and bottom. If it's a different fruit, then obviously you're not looking for that same fruit. So the number of fruit remaining of that same type would depend on what it is on the top, but the number total fruit would change once one's been taken out. So if you did an apple and a banana, it'd be 7/48, and 2 oranges would be 1/20. So rewatch the video. Again, try to think about what situation are you wondering the probability about, and you could find something to apply to your life for this. 2 things you know, 2 things you're wondering, bring them to class, and we'll see you then.